product. We are working in estimating products. And our homework assignment was page 189, 1 through 10. So when we're estimating, we are going to use the skill of rounding to help us to estimate. So we're going to be rounding in order to estimate. Okay, so we want to get a good estimate, which means we need to do some good rounding. Rounding might mean different things depending on the size of your number. If I have a number in the millions, it doesn't really make sense for me to round to the 10th place or the 1st place even. Okay, so sometimes the larger the number is, the larger the decimal place value that we round to, the place value that we round to, the smaller the number, and usually the smaller the place value that we round to. It needs to fit the situation. So number 1, we have 9.7 times 3.3. So that 9.7, I'm going to round that to 10. Times 3.3, I'm going to round that down to 3. That's going to give me an answer of 30. So let's take a look at this estimating. We had 9.7, we rounded it up to 10. We had 3.3, we rounded it down to 3 to give us an estimate of 30. So our estimate is 30. This symbol right here is the looks like a wavy equal sign, means approximately equal to. So this is an estimate. That's what our directions told us. We use 10 times 3 to get 30, which is our estimate. Number 2, these are both also numbers between 0 and 10. So they're single digits to the left of the decimal. So I'm going to round to the nearest 1 place for both of these. And that's not always the case, but in this instance, I am 3.4. I'm going to round that to 3. 5.6, I'm going to round that to 18 or to 6 to get an estimate of 18. So again, I rounded these two numbers to get an estimate of 18. Okay, the rounding helped us to get an accurate estimate. Number 3, 17.5. Now I have, this is a number in the tens place. So we have 2 digits to the left of the decimal. I'm going to go ahead and round that to the nearest 10. If you think of this like money, it would be $17.50. That's very close to $20. So I'm going to round that to 20. 8.4, that's a single digit number. I can easily round that to 8, and I can still do this problem in my head. So I'm looking for estimates that I can use mental math to do. Now, you know that 2 times 8 is 16. You know that 2 times 8 is 16. So 2 times 8 is 16. 20 times 8 is going to be 10 times as much, or 160. Okay, so another way that you can think of this to use mental math is you can think of it as 8 times 2 times 10. 8 times 2 is 16, times 10 is 160. So this gives you the estimate of 160. Number 4, we have 44.8 times 5.1. That 44.8, I'm going to round that to, because I know I can multiply 5s by 5s pretty easily, and I see that that 4.8 is very close to 5. So I'm going to round the 44.8 to 45. And I'm going to use partial products for this example. I did the 45 on purpose, so we can try a different method, because this is really super close to being right in the middle of 40 and 50. So I'm going to leave it at 40 or round it to 45. And then the 5.1 is extremely close to 5. So in my head, I'm going to do this. Instead of thinking of the problem 45 times 5, because I can't do 45 times 5 in my head. Okay, but I can do 5 times 5 in my head. I'm going to leave a little space. And what's 5 times 5? 25. So that took care of the 5 times 5. And then I can also do 40 times 5 in my head. 40 5 times is 200, right? 4 times 5 is 20, so 40 times 5 is 200. So this would be 225. If that was too many steps out loud or thinking out loud, I'm going to actually write this down. This is a good answer. I'm happy with this. I think that you can do this as sixth graders using mental math. If you did not just follow my mental math though, I'm going to break it down with partial products here for you. And that's going to help you to get to the point where you can do these problems in your head. Okay, so here's what I did in my head. In my head, I did 40 times 5, and I added that to 5 times 5, right? So what was 40 times 5? 200. What was 5 times 5? 25. What's 200 plus 25? 225. So you probably learned partial products in 4th grade. If you didn't, that's okay. This is all that it is. Okay. So instead of thinking of the number 45, we break it up into 2 parts. One part is 40, the other part is 5. That's why it's called partial. We broke it up into parts. Okay. Again, this part that's below the box right here, this writing, I'm not requiring you to write that down. You can if that helps you to do the partial products. I just wanted you to see what I'm thinking. I believe you can do 45 times 5 in your head. Next, number 5, 28.21 times 8.02. That 28.21, if you think of it like money, that would be $28.21. That's very close to $30. I'm going to round that to the nearest tens place. 8.02 is very close to 8. I know 8 times 3 is 24. So 8 times 3 times 10 would be 8 times 3 times 8 times 3 would give me 24, times 10 would give me 240. Okay? So approximately 240. Number 6, we have 71 and 9200 times 2. I'm going to round that 71 and 9200 down to 70. So I'm rounding to the nearest tens. And then the 2.01, I'm going to round to 2. We know 7 times 2 is 14. So 70 times 2 would be 10 times as much, or 140. Number 7, on average, the United States produces 36.5 million tons of fruit each year. About how much fruit does it produce in 2.25 years? So if we want to estimate this, 36.5 million tons, we can round that to 40 million tons, so we can say 40. We round that up a little bit, and then let's take a look at the years. 2.25 years, so 2.25 years is very close to 2 years. We just have that extra quarter of a year, so 3 months, we can round that down to 2, especially since we rounded that up, it'll get us close. So 40 times 2 is 80. So about, because this is an estimate, 80 million tons of fruit. $80 million tons of fruit. Is that estimate. Next, we are looking at making headbands. Alicia is making headbands using ribbon. She would like to make 12 headbands. Each one requires 15.5 inches of ribbon. She estimates that she will need to buy 160 inches of ribbon. Is her estimate reasonable? So first, my mind thinks to, well, where did she get this 160 from? I'm going to guess that she rounded the 15.5 up to 16. And 16 times 10 would give me 160. So I'm going to guess that she rounded the 12 headbands down to 10 headbands. Is this estimate reasonable? Not really. Okay, so let's think about this. She needs about 16 inches of ribbon. Okay, she only rounded that up to a half an inch. Only rounded it up by half an inch to get to the 16, but she rounded it down by 2 entire headbands down to 12 headbands. So she's not, if she only buys 160 inches of ribbon, she's going to run out. She won't have enough to make her 12 headbands. Okay. So no, this is not a reasonable estimate. So she only rounded up by half of an inch. Okay. For 12 headbands, but she rounded the number of headbands that she needed, which is 12. She rounded that down by 2 full quantities, and those are each 15.5 inches long. So 31 inches of ribbon she rounded off. She rounded this all the way down to 10. Okay. So rounding this up by a half inch times 10 is not going to, a half of an inch times 10 is only 5 inches. And she rounded down by more than 30 inches when she did that estimate. So no, Leisha's estimate is not reasonable. Um, 160 inches won't be enough ribbon. Make 12 headbands. All right, and then we can say she rounded, she only rounded the amount of ribbon needed per headband up by half of an inch, but she rounded the total number of headbands down to 10, okay? So let's just say she rounded down too far when estimating the headbands. So she rounded the number of headbands down too far. She really can't do that. Okay, and let's too far, F-A-R, not 4. All right, so let's take a look at how much ribbon she'll actually need so we can see how far off her estimate was. So 15.5 times 12, let's just see and make sure that we are correct, which we are, but let's just prove it. 15.5 inches of ribbon per headband times 12 headbands. 2 times 5 is 10, write the 0, carry the 1. 2 times 5 is 10, plus the 1 we carried is 11, write the 1, carry the 1. 2 times 1 is 2, plus 1 is 3. 1 times 5 is 5, 1 times 5 is 5, 1 times 1 is 1. Add these up, 0, 6, 8, 1. And then we had 1 decimal in our problem, so we need 1 decimal in our answer. So 186 is what she actually needs. She actually needs 186 inches of ribbon. Okay. Our next problem, we are looking at wages and financial literacy. Hannah's hourly wage at the ice cream shop is $5.85. The table shows the number of hours she worked. The table shows the number of hours she worked. Let's zoom out to include that table. She estimates her earnings to be $120. Without calculating her actual earnings, determine if her estimate is more or less than her actual earnings, and then explain your reasoning. Okay, so $5.85 is how much she makes per hour. Let's take a look at her table, the number of hours worked here. So I want to get an estimate without actually calculating this. So I'm just going to look for numbers that are easy to add together. 3.5 and 2.5. Half and half is a whole, so that's going to give us 3 plus 3, which is 6. Then I'm looking at the cents or the partial hours here. This is 75 hundredths of an hour and 25 hundredths of an hour, which is 1 hour. Okay, together here. So I can add that to this to make it a 4. So 4 plus 4 is 8. And here we have 4.75 hours. We'll round that to 5. That's going to give us a really close estimate. We only underestimated by 1/4 of an hour. Okay. So this would be 19 hours, right? 6 plus 8 is 14, plus 5 is 19. We know we underestimated by just a little bit. So 19 hours, okay? Then her wage is $5.85. So it looks like Hannah rounded this wage to 6. And it looks like she rounded the hours to 20 to get 120, okay, dollars for the week. Well, is her estimate more or less? Okay, her estimate is more because, so Hannah's estimate is more than her actual earnings because she rounded up her wage and she rounded up her hours. Okay, so she didn't actually make $6 per hour. She only made $5.85 per hour. She didn't actually work 20 hours. She worked closer to 19 hours. Okay, it's an estimate. So we didn't do her actual calculations, but we know she estimated high. She'll get close. That's a good estimate. It's actually a great estimate, but it's a little higher than what the actual earnings are. Number 10, a car releases 19.6 pounds of carbon dioxide for every 1 gallon of gasoline burned. Estimate the number of pounds of carbon dioxide released if 14.5 gallons are burned. So we want an estimate. So 19.6 pounds of carbon dioxide per gallon. So with the 19.6, we can round this to 20. And the 14.5, we can round that to 15. So if we burn 15 gallons of gasoline, which is about an average tank of gas, times 20 pounds of carbon dioxide. So we can say 15 times 2 is 30. So 15 times 20 would be 300. So about 300 pounds of carbon dioxide. Okay. I'm going to add the word about because it's an estimate. So that was lesson 3.2, estimate products. We just did the problems on page 189 together.